Let me elaborate on the concept of tolerances in GD&T. Tolerances represent the acceptable amount of variation in a physical dimension, and they play a crucial role in engineering design and manufacturing. It's essential to understand that tolerances are not necessarily visible to the naked eye, but they significantly impact the performance of a part or assembly. Even with precise CNC machining, parts may still have imperfections that are allowed within the specified tolerance limits. These limits are intentionally set to account for the natural variations that occur during the manufacturing process. As a general rule, engineers and designers should aim to keep tolerances as large as possible while ensuring the part functions correctly. This approach helps minimize costs associated with manufacturing, inspection, and tooling. Tight tolerances can increase costs and are only necessary in specific situations. To put tolerances into perspective, consider the diameter of an average human hair, which is approximately 0.005 inches. Modern CNC mills can achieve tolerances of plus or minus 0.005 inches, but that doesn't mean it's always necessary or cost-effective to do so. Here are some key takeaways. Tolerances are a critical aspect of GD&T and impact part performance. Imperfections are inherent in manufacturing, and tolerances account for these variations. Engineers should aim to keep tolerances as large as possible while maintaining part functionality. Tight tolerances increase costs and are only necessary in specific situations. The diameter of a human hair, 0.005 inches, serves as a reference point for understanding tolerances. By understanding tolerances and striking a balance between precision and cost, engineers and designers can create effective and efficient designs that meet performance requirements while minimizing expenses.